Hello and welcome to the presentation on Doppler. Here I will talk about very basics of Doppler. In-depth discussion of Doppler is beyond the scope of this presentation. So why Doppler? What is the difference between the Doppler and the grayscale image? The grayscale image is caused by reflection from the tissue interfaces, whereas the Doppler signal is caused by tissue movements. The best grayscale image is obtained when the sound beam hits the interface at 90 degrees, but the best Doppler signal is obtained when the sound beam is parallel to the flow. Doppler sonography is used to image tissue movements. The Doppler effect is change in frequency of sound beam due to relative motion between a sound source and a receiver. Change in frequency is known as Doppler shift or Doppler frequency. So the Doppler frequency or Doppler shift is equal to received frequency minus transmitted frequency. Now here is your Doppler equation. The Doppler equation states the relationship between the different variables which affect the Doppler shift, which include the transducer frequency, the velocity of blood, and the angle between the sound beam and the direction of blood flow. Here are the commonly used modes of Doppler sonography. The spectral Doppler records the tissue movements in the form of a graphic display, whereas the color Doppler records the tissue movements as a visual display of colors. The color Doppler and power Doppler are most useful in musculoskeletal sonography. The wall filter setting is very important when looking for low velocity flow. The wall filters block signals from vessel wall. The signals from vessel wall have low frequency shift but have a high amplitude. For color Doppler, wall filter setting changes with the change of PRF. It means the PRF and wall filters are linked together, so they go hand in hand. So increasing the PRF increases the filtering threshold. So let's look at these two color maps. The color map 1 shows you a PRF setting which gives you a velocity range from plus and minus 60 centimeters per second. So the wall filter gets automatically set at plus minus 6 centimeters. So you will be filtering out any speed which is either plus or minus, means is positive or negative signal of 6 centimeters per second. On the other hand, the color map 2 shows you a setting of plus minus 40 centimeters per second, and the wall filter is automatically set at plus minus 4 centimeters per second. So hence use the lowest possible PRF to avoid filtering out the low frequency signals of blood flow. Here is my recommendation for optimum settings for a good quality Doppler image. So what I want to tell you, maximize the power output of your machine and increase the gain till a random noise appears, and then lower it till the noise movement just disappears. Try different frequencies till a best signal is obtained. Higher frequencies are more sensitive to flow but subject to attenuation. Use low PRF between half and 1 kilohertz. Use smallest possible color box to include your region of interest. Avoid pressure during scanning to maintain blood flow.